Hello, Assalamu alaikum everyone. This is Zainab from DICE Analytics. I would like to extend a very warm welcome to all of you on behalf of DICE to the round one of DICE Ramazan Webinar Series 2022, Best Practices for Getting Started on AWS. We are very glad to announce that today's webinar will be conducted by Mr. Mohammed Munib. Mr. Munib is a data professional with 4+ years of experience in data analytics domain. He has worked in 4 different industries in roles of data engineer, solution engineer, and currently working as a lead data engineer for a leading pharmaceutical in data governance team. In today's session, you will get to understand the best practices for getting started in AWS Cloud. You will learn the best practices to build resilient, reliable, and cost-effective applications. You will get to know how to structure your AWS accounts, use consolidated billing, and how to securely control access through AWS identity and access management, and much more. I would like to request all of you to note down your queries during the session and ask them in the Q&A session at the end. That's all from my side. Thank you so much. Over to Mr. Munib.
Everyone, Munib here, and I think pretty much my introduction is not really needed at this moment, but Zainab has gone through it in a very detail. Today we'll be going through the introduction to AWS. A couple of things that I want to convey at the start of this session. That is that we will be focusing on more towards a data analytics / data engineering journey rather than encompass everything that is included in AWS. A couple of misconceptions that people have generally when speaking about cloud in general is that whenever somebody asks what is cloud, the first thing comes to mind is it's a storage space. And I think one of the reasons for that may be that we are so used to using services like Dropbox or some services that could be your picture sharing sites. So whenever cloud comes to mind, it's first thing, okay, it's just we are going to talk about storage. But I want to emphasize this at the start, even though our entire talk will be focused around data, its journey in storage, its transitioning from one platform to another. But keep in mind that cloud is not just about data or storage. It has a lot of other features. You can even build apps using AWS Beanstalk and deploy it without any infrastructure on your premise. So as we are evolving more towards the cloud infrastructure, a lot of the functionalities that was only available on-premise or was only available on your desktop, that you could build your entire apps only on the machine itself, it's slowly migrating towards cloud as well. So one of the reasons that why cloud is mainly associated with storage is because that's where the journey started. So keeping that in mind, I would like this session to be a little bit more open-ended. So if you guys have questions, I will stop in between the discussion so we can go through those questions as well. If there is something that is not really covered in the seminar, I will have at the end of the session like 20 minutes, and we can go through those details if you have any of those questions, because mainly this is for an introductory section. So it's not going to be going very in-depth in the technology stack. Also at the very end, for like 5 to 10 minutes, I would like to use that time to give you some and give you some resources that you can actually use to get started on the AWS journey. So keeping that in mind, let's start the webinar. Everyone, welcome to this today's session. So right now we'll be so our outline will be our journey for data engineering toolkits. What is AWS? That will be my first thing. I will be skipping the first two for the time being, and I'll be coming back to those later on once we are more familiar with the AWS platform itself. Then engineering challenges and AWS engineering. That will be the main crux of the session itself. Can people see my screen? I see a question that they're not able to see it. Should be visible.
Yes, it's visible.
Okay. Now coming back, so what is AWS? So a lot of the buzzwords are about AWS in the community. First of all, it's Amazon Web Services. So it's everything that Amazon has in its offering in a web structure, web space. So when we are talking about what it has in offering, so it's not just going to be storage, which is mainly and generally related to an S3 storage bucket or something like that. It could be an RDS data store. Okay. So when you're talking about, okay, I have deployed Postgres on AWS, that might be an AWS offering. Then some people use AWS services in a networking environment where they are actually using it for their networking. Then comes that some people have some transformations or some jobs that they are running on AWS Lambda might be. So that is another AWS services. So a lot of the services that AWS offer comes under the AWS umbrella, and they are mainly concerned with usability. So it's going to be very technology related, and a lot of it is going to be towards data. But I'm a little bit partial in that sense that since my understanding and my usage is very towards the data itself. And also another reason is that this misconception is going to be very prevalent is that's where the journey for the cloud itself started. That's where it started offering the storage, then slowly they moved towards databases and stuff like that. So that is why. Now, when we are talking about cloud itself and AWS, there are other competitors in the market as well. We have Microsoft Azure, which encompasses a large portion of the industry as well as Google Cloud. And there will be some small competitors as well. But I think you will be, whenever you are listening to different people or you're working on different environments, especially a production grade system for a corporate is going to be one of these three cloud service providers. And if we are talking about cloud, then the one that is the most prevalent of all is AWS. Now, when we are talking about we are working on AWS, you will be seeing people, some who are using it for their storage capacity. It could be you can just go ahead and store your pictures on in an S3 bucket, and it's the free tier is actually going to allow you to do this up to 5 GB. And I will discuss the free tier at the end of the session, how you can get it started on this. Now, why industries are more interested in AWS now as compared to before. Okay, so like previously, what infrastructure was all about was you need to have some hardware if you want to get into the industry, and this was very prevalent for everyone. If you want to do something, if you want to build up a service provider company, you need to have some infrastructure in form of some racks, some storage, some networking capability, everything. So whenever they had to do is you have to first invest a lot of money into actually getting used to bringing these things into your area, and then you have to set it up, and then afterwards you have to take care of the infrastructure as well. Now that's where the use for AWS is getting very prevalent, because you don't have to do any of these kind of things. Okay, what you have to do is, as we will see later on as well, you just need to have an account, and then you need to know what services you need. That's all your knowledge is. And once you get started, you only pay for the services you use and nothing else. So you don't pay for the rent of those services where they are live. That's none of your business. You're just going to pay for. So when we say what we are going to pay, I run a job on, let's say, an AWS Lambda function, which is processing engine. So it's not, I run the job and the job runs for 5 minutes. That's all. Since it ran for 5 minutes, that's all I need to pay. I don't need to worry about anything else. Next time my job ran for 4 minutes, I'm going to pay for 4 minutes. So that is where the power of AWS itself is coming into the position. And mainly when we are talking about AWS is, as I said before, it's regarding on-prem systems and off-prem systems. Okay, so when we are talking about on-prem systems, it's when you have a data census in place. So there is a machine installed, there are servers installed, there are different networking devices installed. You actually have dedicated power to that system. You have actually backup servers to that system. So everything is on premise. You own everything. So if you need to start an on-premise system, you need to have a very big capital to start investing in that. You need to have those servers, you need to buy machines, you need to buy network devices, and then you have to install everything on those devices. Then you need to maintain those devices. Then you need to ensure security for those devices. So that is an on-premise system. And a lot of the industry previously, for if you, as far as you go back like 5 years, a lot of the industry was prevalent in this kind of infrastructure. They, whenever something was needed to be done, they had to buy new servers, everything needed to be done that. But for the past couple of years, like 3 years, in Pakistan, the familiarization with cloud is becoming a little bit easier, as we are entering in a global market now, where this has been prevalent for a while now. We see companies that are very sophisticated in cloud already, because they invested in it 10 years back than us. So that is why you might not have heard cloud that much, and you have only heard the buzzword. Okay, what is cloud? Okay, I heard a cloud, something like that. So just keep in mind that cloud is whenever you don't own anything and you can still use the services and you only pay for that duration. It's going to be, we are talking about something in the cloud. You are not talking about an on-premise system. Okay, so this is just a service example. Now, as I said before, there are different cloud providers. One of the main three that is part of the business is AWS, Azure, and Google Cloud. Okay, then there is IBM Cloud, Oracle Cloud, and Alibaba Cloud as well. Uh, all of the of all these six, the main prevalent ones are AWS and Azure and Google Cloud, mainly because of the offerings they have and how much the business they have in a global setting. So whenever you are talking about cloud, so I think I need to add one more thing. Whenever we are talking about cloud, and I keep saying that you don't own the infrastructure, but keep in mind that there is an infrastructure, and even though you don't manage it, someone have to manage it. Okay, so we are talking about virtual servers. There's, at the end of the day, there will be a server. You are not concerned with it, but a company like AWS is concerned a lot with it. So when I say global presence, what I mean by this is how much presence the company has in a global environment. For example, AWS has servers all around the world. The closest for us is India, but I believe a lot of the companies in Pakistan don't utilize those servers. It's mainly we are going to be using the UAE or other sites for or Malaysian sites. So that is something. And but in that regard, AWS has the biggest presence in that department. Then comes Microsoft Azure, and it's a very prominent figure. You can hear this one especially in the UAE region. So whenever there is a cloud presence, it's mainly towards Azure. And there is also Google Cloud, and IBM has been in the market for a very long time, and they have been making machines, and afterwards now they are moving and transitioning towards cloud as well. Oracle is also one of the main competitors. Now Alibaba is another competitor, but you won't be hearing a lot about him in the general industry. And the main reason, there is no complication in that department. It's mainly because of it's a Chinese origin. So a lot of the Western companies are a little bit hesitant in that department. Now, since we are on the same page, I would like to. I have been saying these words, and I think it's better if I explain these right now. So whenever there are talks about AWS, some keywords that are coming again and again for anyone is Amazon EC2, AWS Lambda, and Amazon S3, Simple Storage Service. So since our concern is regarding this one as well, so what is Amazon EC2? Also, I just need to add, if you have a question, you can raise your hand or you can ask the question in itself, and I will go through it in small intervals. Okay. So now coming back to whenever you are getting started with AWS in itself, the first thing you, at least what I did, and you should be doing is getting yourself familiarized with Amazon EC2. So what is Amazon EC2 itself? So now Amazon EC2 is just elastic compute store capacity. So now it's virtual servers, okay? And when I'm talking about virtual servers, it means that it's a server that is available to you, and it behaves like an actual server that is like an on-premise server to you. But you do not have any concern with the infrastructure itself. Now, whenever we are talking about servers, the first thing comes to mind a Unix or a Ubuntu system. But keep this in mind that Amazon EC2 is not just Unix or a Red Hat server. It can be anything. It can be a Windows server as well. Okay, and in some of the offerings, they are now offering Mac OS services as well. So now, when we are talking about servers, why do we actually need a virtual server? Okay, so this the reason that we might be needing Amazon EC2 is that we want to run something, and we need an actual development kind of capacity, meaning that we want to have the entire server itself and capable of doing everything and everything onto that server. Okay, I want to make an application, but I know I'm going to be using some very proprietary libraries in that capacity, and I don't want it to be exposed to anyone, and I want to ensure that I have the full reign on everything within the infrastructure. Also, I'm going to make some changes in the system kernel as well. I'm going to change those settings, everything. So if that is your requirement, then Amazon EC2 is going to be your go-to. And Amazon EC2 is very easy to configure. What you need to know is you just need to configure an AMI, an image of the actual machine you want to run. Okay, then you need to just assign it some storage. As you already know, you always, whenever you need to run anything, you need that storage capacity to be associated with the Amazon EC2. And afterwards, you need some networking as well, but you can keep it as private as well in that department. So launching an Amazon EC2 instance is just like on a few clicks, and you can go through that. And we can check it if people want to know at the end of the session. Now, another microservices architecture. So now there are a couple of things that that are associated with AWS Lambda. So that is microservices, and then we also have serverless capacity. Okay, so what is serverless capacity, or what is microservices architecture? So a serverless service is when you actually are you're not concerned with anything of the server itself. In Amazon EC2, you were concerned about the virtual server itself. But when we come over to AWS Lambda, you don't need to worry about it. You just need to tell your running engine that you will be using for executing any stuff on Lambda. And once that is done, it's up to AWS to provide you that capacity for the actual job to be run. So you just need your code. It's going to run it. It's going to run on a serverless engine. You are not concerned with settings of that server, anything like that. AWS is going to take care of it. And it's AWS is only going to charge you when your application is done and it has used some capacity. So just like I gave you the example previously, that you are running AWS Lambda, and you ran a job. For example, I ran the hello world job. It ran for 2 seconds and I printed hello words like 10 times. So I'm going to only pay for 2 minutes. Now there is another job that I am using to offload some data from my laptop to Amazon S3. And the job, what it does is just picks the data up from my laptop and places it into the Amazon S3 bucket. And that job ran for 11 seconds for all of it. So I'm going to get charged for 11 seconds. Now, how did AWS do it? what kind of server capacity it used? Did it use Red Hat in the backend? It used Unix, or was it there is a Windows server, or did it have any other services that it used without or its proprietary engine? I have nothing to do with that. My concern is only going to be with the language itself that I'm going to use for running the code. And as far as the code is good to go and it doesn't have any errors or it doesn't have any issues in itself, it's going to run. And once the timer is up and my job is done, AWS is going to let me know, okay, your job ran for this many time and this much resources were used, and we charge this much for 1 second. You are going to pay for 11 seconds that you used our services for. That's all. And I'm done with that. Now, if we were to translate this very same thing into an actual on-premise or ownership kind of thing and disconnect it from the cloud. For example, if there was a very expensive job and you need an expensive PC to run that job. So you need a PC with a GPU and a CPU that is capable of running that job. A very good example that I have come across a couple of times is whenever you're running your data science models, it's usually you need to have a very good machine if you want to run it yourself. You don't want to offload anything. You want to have everything to yourself. You don't want to run the code anywhere else. You need a good machine to run those models. Otherwise, it's going to just elongate your time itself. But when it comes to AWS Lambda, it scales automatically. So you don't have to worry about, you can run multiple threads at the same time. It's going to give you that capacity. Of course, you're going to pay more, but at the same time, you're going to save the time in this capacity. So you don't need to worry about the hardware. You don't need to worry about what's going on. You just run your job and that's all. Okay. So that is a serverless capacity. Now, another thing that is coming whenever you're talking about data engineering in general or cloud, it's going to be storage. You need a storage capacity to save anything in the environment. So whenever we are talking about storage, we first things that is related to AWS that will be coming to your mind is Amazon Simple Storage Service. And just like its name, it's very simple storage. You don't need to worry about anything like that. You just drag and drop and it will have a couple of things that are related to AWS storage services. So the architecture for AWS S3 is that you need to specify a name, which is called a bucket name. Okay. So whenever you're talking about S3 or simple storage service, it's related to a bucket. That's why the sign bucket is there. And that name needs to be unique all around the world. And there are a couple of reasons for that as well, because you can make S3 buckets public. And also there is a very simple exercise that everyone should try if they get a chance. And using the free tier itself, you can make a static website in using Amazon S3. So that is, there are a couple of reasons that since they are bound to itself, you need to have a unique name. So for example, if I chose a name AWS Dice Analytics, you cannot choose it now. It's going to be unique. And now another thing is Amazon's S3 is storage by it's very plain and bland. You can have familiarization or kind of representation of directories and stuff, like you can make directories and you can put data in there specifically. But on a very high level, those directories are just for your viewership. In itself, Amazon S3 is going to treat them as is it is. It's going to be plain, simple, those files. So whatever directories are there, it's not going to be the directory. Okay. We have a question. The question is, what is the main difference between AWS EC2 and AWS Lambda? As it is mentioned that both comes under compute category, and for both we are not responsible for underlying infrastructure. So what is that's a very good question. Okay, so let me I think the reason these two comes under compute, that is your question, that's the point. Now it comes, it's not just as simple as that it's going to be compute. It's that how much you have to still take care of the system. Okay. Now let's take the, I think I missed a point as well. And the question brings us back to the that point. So now we don't, in both of these, we don't worry about what you call infrastructure itself. So we don't have to take care of overhead of the infrastructure. Now there is another concept that you have to take care of into the cloud is it's going to be your operational overhead. So what is operational overhead? So operational overhead is that when you have capacity, how you need to operationally manage it. Okay. So when I say operationally manage it, now let's relate both of these services and try to understand what is operational management. For Amazon EC2, if you try to uh, procure a server of EC2, it's going to require you to, for example, you chose a Unix or Red Hat server. Okay, you said I'm going to have a Red Hat AMI for my Amazon EC2 instance. It's going to ask you a couple of things. Okay, what kind of storage you need, stuff like that. And okay, here you go. It's your EC2 instance. And now what you did is you just use a client like a Putty client or Amazon's own CMD, and you logged into that server, and it's going to give you a command line interface. Now you have the complete operational capability on that EC2 instance. For example, you can take care of any libraries. You want to install another utility in the EC2 instance, you can install it. You can take care of the server itself. There are, if you want to install a database there, and there are dependencies in that what you call database, precisely, you are going to take care of those responsible or dependencies yourself. 2 days pass and you decide, okay, I need to install another application that is going to be used for my infrastructure. You need to take care of that. So that is going to be your operational overhead for Amazon EC2. If there are any dependencies or anything needs to be taken care of in an Amazon EC2 environment, you need to make sure and take care of it yourself. So EC2 is going to give you that virtual kind of thing, and but at the same time you need to be responsible for that virtual server. The security of that virtual server is your responsibility as well, and everything related to that EC2 instance, who it can communicate to, where it will communicate to, what it can do, stuff like that, it's completely up to you. Now let's come to an AWS Lambda. AWS Lambda is not going to ask you these kind of questions. Okay, what you need, it's going to ask you is, okay, you're going to run some code. Okay, I understand what language you're going to use. You're going to tell it your language. You're going to put in the what you call your code in itself, and then all you have to do is just run it, and it's going to take care of the infrastructure as well as the dependencies that are related to that. So some dependency, like if you have some images in itself in your code that needs to be embedded, you need to provide that. But that is not the concern. If there are underlying packages that are involved with the core OS, you don't need to worry about that. What you need to worry about is you need to ensure that your code is good and it's able to run on itself. Now coming to the other, like for example, you need to worry, don't worry about is Python installed or not? Do I need to install it? Do I need to install the Python packages as well? Do I need to do this? Do I need to do that? No, that's not your job. It's going to take care of itself. Another thing that I need to mention is compute services. Amazon EC2 and Amazon Lambda do come into the same umbrella, but its usability wise, they are very different as well. Usually, whenever there is a code line understanding of what AWS Lambda is going to do, it could be like you're running a PySpark job and you ran that job on AWS Lambda. It's going to run your code itself. It's going to move data around. But usually when we are talking about, we want to have more control over applications, which could be like you have an on-premise system and it was running Oracle, for example, and you want to have that license over there as well, and you want to have the same picture that you previously had. You want to control that operational overhead. You want to ensure that I'm going to take care of everything. I'm going to install everything onto the server. So that is where the EC2 comes in. But if you're not familiar with, you're not concerned with these kind of stuff, and you just want to run some code and done with the stuff itself, you just procure your code onto the AWS Lambda, and that's simple as that. So that is the difference between these two computer services. Although they are basically different as well, like EC2 gives you more control, but at the same time, you have to negotiate something on the operational overhead kind of thing. But if you come over to AWS Lambda, it's not going to tell you it's serverless. It's going to expand itself. But of course, you won't have that control that you might want to have in certain environments. Some industries usually, even if they have code that can be ran on Lambda, won't be running it over there because they are compliant to uh, some rules of that country or maybe industry itself. So they are bound to run it on a controlled environment of an EC2 instance. And EC2 instance is going to be very, very similar to a server itself. So if you just try to run a virtual server using some VMware software, it's going to be same as that. Okay, and also I think for simple storage, you need to. I don't think so. There is any bound. You don't need to worry about that what you are storing there. So you can store any raw data over there. You can store TXT, PDF. Everything is going to be just in a storage capacity. Okay, so that is going to be a storage subset. And keep this in mind that it's a simple storage. So it's not in any format, and it's not going to bind you in that format as well, that you can do whatever you want. In Azure, I'm aware of block storage in a very similar way that is going to be allow you to store any kind of thing. So that is something. So in that way, but at the same time, it's going to be a raw storage. It's not going to be what you call uh, a very formatted kind of storage. So your system might not be that into it. Usually, whenever we are talking about S3, it's going to be used as a storage service for an oversight application. So for example, if you have some semi-structured data, you can just store it as it is and build your application on top of it. That is going to be utilizing that data, and it can be stored in this fashion. Now, another thing is that is very prominent for AWS, and I think all of these five things that we are trying to discuss cover a very major part of the industry. So it's going to be Amazon Aurora and Amazon RDS. So let's start with Amazon RDS, and then we can come back to Aurora itself. So what Amazon RDS is? Amazon RDS is a storage service. Now it's going to have, whenever you're talking about Amazon RDS, it's going to then be associated with a flavor itself. So what I'm saying, referring to flavor, is when you're talking about Amazon RDS, it's going to be Amazon RDS Postgres, Amazon RDS MySQL Server, Amazon RDS SQL Server, stuff like that. So there will be a relationship with that. The reason Amazon Relational Data Store is associated with engine is they haven't replaced the engine itself. So that is coming to come to Aurora itself. So what it says that you can have the same capability of your on-premise system onto Amazon, and it's going to give you everything in that environment. And Amazon even offers utilities that can take your on-premise data of Postgres database and shift it onto RDS, and it's going to be just like a couple of clicks, and your data is from here to there in no time. So Amazon RDS is going to be it's a data store, so it's not really very different. There are going to be tables and stuff like that. That is going to be same regardless of what you basically have. So Amazon RDS is going to provide you that table-like structure and table-like engine that you can use in a cloud AWS platform. So if you want to run a Postgres database in Amazon, you have decided that it's going to be Postgres, then you can go with Amazon RDS and just choose the flavor as Postgres, and it's going to give you that storage space. And another thing is, the example is the same thing that came to compute as well. You can actually go ahead and procure Amazon EC2 instance, and you can install a Postgres database over there as well, and then use it as it is. That's going to behave like Amazon RDS. But the question for that comes to mind is how you want to manage that infrastructure. If you are sure that you need to have full control of the system, where that system, virtual system, where that database is going to lie, you need to have a kernel level and OS level capabilities to be able to basically do anything. And you are confident that you don't need the latest version, but rather you are going to use industry recognized and your company improved version, that you might have to go with an EC2 instance approach. But if you want the operational overhead to be a little bit lesser, and you will have to take care of like versioning and replication and duplication kind of stuff, but they are still on a very you can say pick and choose kind of manner. They are not on a very systematic level. So if you have to have the complete control, then you might want to procure some EC2 instance and then come back to install the Postgres database there. But if you want to have Postgres and you want Amazon to take care of some tasks, like you want for operational side, but you want to have the best performance, then yeah, Amazon RDS is going to be your go-to in this department. Now, Amazon Aurora is a little bit of a new in the database storage capacity for Amazon as well. And it's when we are talking about Aurora, it's a little bit in limited capacity. When I say it's limited, that it's only available in MySQL and Postgres flavors at the moment. If you'd have any other flavors available, you won't be able to use it. And it's a little bit of an offering from Amazon precisely, and it offers you a very robust and fast system. So it's going to Amazon pushing a lot towards Amazon Aurora for some time now. And even if we are talking about the prices point, it's very comparable to Amazon RDS itself, and it's behaved from operational point very similar as well. But you are going to have some features of replication and read replicas kind of thing that is going to make your audience a lot more happier in terms of response times. So your data will be replicated and in a fashion that people who are actually trying to reach, or your application or your systems that are actually trying to reach from a global side will be very easier to get a hold of these things. So Amazon is pushing towards it, but it still comes to price point. It's higher, but I think you can only use Postgres and MySQL at the moment. Other than that, RDS does offer a lot of other data stores as well as SQL servers and stuff like that. So if you are running some other, of course, you cannot really use these two servers. Okay, I think we have some other questions. So before I move to other side, if someone else has a question as well that is incorporated in this one, you can put it in chat, and then afterwards I'll be moving to the next question. So any limit of storage on S3, is it unlimited? What is underlying file system use? So the underlying file system is not going to, it's not going to restrict you in that capacity that you must use the TXT file system. No, it's not. You can have the same, you can have TXT files, you can have, so it's not, the underlying file system is completely up to you. Of course, if your application that you have built that is going to be using this S3 bucket can only read text file, then of course you don't need to put those pictures in there. That's your logical understanding of the system, how you logically build the system. You can make like 3 buckets. One has only my tabular data in there, one has text data in there, one has pictures in there. So that's your logical understanding. S3 is not going to restrict you that only these kind of files can be put into Amazon S3. That's not really S3's job. it's it's going to come down to you how you're going to use a particular bucket in itself. But as far as limitations are concerned regarding the file types, there aren't no limitations. And also for storage, I'm not aware of any S3 limits in terms of storage overall. There are some what you call file size limits that you can only go as far as this size. I need I think it's like 10 GB. You can only put a certain amount of file in there, but it's in terabyte. I will confirm on that topic, but as far as concerned is that you can only have uh, 10 TB of data. That is not going to be the limiting factor in there. It's going to be the limiting factor that what can be the size for a particular file. There is a max limit. I need to check, but since it's been a while, looking that, so I can get back to it at the end as well. But as far as storage is concerned, it's not going to cap you. You can have the maximum size, file size for 70 GB, and you can have 100 of those 70 GB files. There is no limiting factor. Also, it's a lot resilient, but since we are going to come to those topics a little bit in a while, so we can come back to it again. The other question is, let's suppose I have a database on-premise and an Amazon RDS in cloud. Do Amazon RDS support master-slave infrastructure in this situation? So it's going to be master-slaves you can, but it's still going to have a little bit of impact on yourself, because you have defined that master slave infrastructure and you need to define, there are a couple of services that you can use in the networking layer that can define that where the data is. Now it's going to come to your side as well, that your master data source is, for example, creating data for the entire day. And now you need to offload that data onto your AWS Cloud RDS. So it can offload that data, but when you want to transfer out that data onto the your cloud, and also the services that are going to be used for that won't be related to RDS itself. It's going to be separate. But when we are talking about Amazon RDS, it's not usually master slave relationship over here. It's usually towards read replicas kind of thing. So what are read replicas? It's going to be if you are sure that your application is read a lot more as compared to inserting new data, that you can have read replicas. So what we'll do is it's going to make your system a lot more easily accessible. But in a master slave relationship, it's usually for a purpose, and the purpose need to be either you have a system generating data, and then you are going to use a slave system to basically have a backup of that system. So if you want to do that, build that kind of relationship, you need to logically build that relationship and ensure that data is offloaded as well. And it's not going to be taken care of Amazon RDS as well. I believe it's going to be a database management service of Amazon that is going to take care of that for you, offloading that data onto Amazon RDS as well. And a couple of other things that are a concern, you need to ensure that versioning and stuff like that is in align with RDS as well. So you cannot just have Postgres data put into MySQL server. You can do that, but it's going to be a little bit of a different service. You need to transfer that kind of schemas and stuff onto the other platform. So Amazon has a transfer service as well, but it's going to be different. Also, they do have, in terms of storage, they have transfer services as well, but they are more related to Amazon S3 and S-Stack. Amazon S3, I have only gone through it in a very broader sense, but keep in mind there are very different kinds of S3 buckets. So it's not just S3. There are going to be S3 standard. Then you have frequently access, infrequently access, cold storages, your ledgers. So Amazon S3 further divides into a lot of things, and they cost very differently. they have a retention differently. Well, it's like 11 nines, and some are like 9 nines. So it's very close of percent of durability. So keep this factor in mind that when I'm talking about Amazon S3, it's in a very generic sense. But when we are talking about in detail, there might be you have to look into if you want to use Amazon S3 in standard format, or if you want to use Amazon S3 in a cold storage format that you are just going to keep your backup copies over there. Okay. The other question is there any authentication authorization mechanism provided to access and store files on S3? Can we allow a file stored on S3 to be accessed for a certain period of time? So there is a way for that, but it's going to be the lifecycle policy itself. You can set up a lifecycle policy if you want to have a file for a certain period of time, and afterwards you don't want to save. But usually lifecycle policies are used in a different capacity. Whenever you delete something in Amazon S3, it's not actually deleted. It's more of a there is a flag that is put into place for that. So if you want to ensure that it's deleted permanently, you need to ensure that yes, you go ahead. It's possible programmatically as well, but you need to pass that flag over there that yes, just completely delete it. And if you are talking through the UI itself, you can just go into the bucket, you will delete it, and it will put a flag there. And if you remove that flag, it will come back into the accessibility phase. But if you want to remove it completely, it will ask you again, do you want to completely remove it? Because retention and durability is one of the main factors for Amazon S3. To give you an example, if your file was stored on what you call in Malaysian servers, and Malaysian servers go down, there was a fire, and one specific server got caught on fire, and your file was there, it's going to ensure that you have that file. It's going to make that copy and make you available. Of course, that it might not be able to provide you in Malaysia itself. It might give you an option, another region, but you can even restrict regions as well. So in depth, if you go, you can restrict it that this should not leave this region. And for other, yes, there are authorization. There are SC policies as well as you can use AWS policy management itself. So you can use both. Amazon S3 offers S3 policies that are directly linked to Amazon S3 buckets that define who can actually access this bucket and who cannot even see it. Usually they are used in a format that these applications are only allowed to access these S3 buckets, and this could be restricted to an EC2 instance or Lambda, or it can be generic that yes, Amazon EC2 instances in my VPC can use this bucket, and it can be that no a very specific EC2 instance with this IP address, when this sends request, this can use it, or you can just go ahead and create a policy completely new blank in the IAM service, which is one of the services for authentication and authorization for AWS. So you can go ahead and create an IAM policy and try to control it in that format. So it depends of how you want to restrict the access itself. A lot of the time, usually people prefer S3 policies because they allow you to they allow you to directly be linked into that bucket and keep that environment in there. But if you are in a position that you think the same policy will be applied to multiple S3 bucket, then maybe it's better to use an IAM policy rather than an S3 policy. So yeah, that is pretty much, I think I answered the question. There's still some confusion. Do ping in the chat. There's some confusion. Okay. Now, coming back, I was talking about that global infrastructure. So this is pretty much the picture that AWS has of their global presence. It's pretty much available in, they define, so one thing is they define their presence in terms of regions. So it's going to be a region that they going to tell you that we operate in this region, and it's going to be an entity. It could be Australia, it could be US, and it could be India. India has a very big presence as well. And then when we are talking about AWS regions, there isn't going to be just one, what kind of, one space that they have their entire infrastructure. That is not going to be the case. Like in India, there is not the case that they have everything in one building and that's all. They're going to have multiple sub AZs, so it's called availability zones, and usually one region consists of at least 3 AZs, but it could be it can be easily more than that. So what's going to happen is when you ask it not to leave that region, that and the service you are using is durable, it's going to ensure that it's replicated in different AZs, and AZs are not linked in any fashion. They are separate in terms of infrastructure, in terms of actual existing place. So they are not like connected buildings, and one is called AZ1 and one is called no. They are going to be in one region, different separate infrastructure and separate buildings itself that is going to represent an AZ, so that in terms of any failure, and if you have services that use multi-AZ for durability, that it can be replicated in multiple places that are separated in terms of networking and stuff like that, but they can ensure that in terms of any disaster, your data is not 100% lost. So you have still a way to recover that data. There could be a chance that if you are getting your data recovered in a couple of seconds, now you might have to wait a couple of minutes because that multi-AZ replication might have been a cold storage, or if there was a disaster and a specific AZ went down, there are a lot of requests, but it's going to ensure that you have that data available. And also, as soon as uh, an issue happens, usually uh, AWS takes care of it altogether itself. It's not going to ask you to interfere and replicate your data. It's going to happen again itself. And also, one thing that is used for AZ as well is whenever AWS is trying to retire some systems. So if you are using an old system and AWS is going to retire and just it happens that there is no other space available in that AZ, it's going to ensure that your data is moved to another AZ. So that is something AWS is doing. I see some hands up. Okay, but have you seen people hosting their personal portfolio in S3? So would you say Lambda is yeah, so PaaS, SaaS, and IaaS are some terminologies that are used in cloud. I was not going to go there in itself, but just to give you as stands for infrastructure as a service. When you are trying to procure infrastructure, and you're going to take care of that infrastructure in itself. And platform and software as a service are going to be a bit of a conundrum. A lot of the time, the applications fall in either of those two. So platform and services, whenever you're trying to procure a platform, the main difference is platform is going to be uh, platform is going to have to, you need to take care of that platform itself. So you need to ensure that it's up to date and its dependencies are clear. While software is going to be just you are using. The reason if, what you call AWS Lambda, it's not really related to either of those. At least I try to say it. it's more of a serverless capacity that you are not required to take care of anything, more or less. So that is something that is going to be different for us in these kind of environments. Okay, let's move on. So advantages of cloud, we have gone through a lot of details for AWS itself, and let's just take care of some of the advantages itself. You can go global in this question. Um, okay, I see a hand raised, but um, yeah. So yeah, Asim, there won't be any hands-on in this session since we don't have really the time to actually take care of the hands-on. So there won't be any hands-on. It is mainly going to be just an introduction to the AWS cloud itself and what are some of the very basic capabilities that it has. And at the end, I'm just going to review if you want to get started with AWS and want to get used to it. You can use some resources that we have for this purpose. But as far as hands-on is concerned, if I start hands-on, it won't be possible for me to cover the details. So, for example, yeah, we will see some examples as well. Some of the companies that are using the cloud itself. So now coming back to the when we say we can go global in minutes, it means that you have an application that is very catered toward a specific demographic, and you use that application in your region or area, uh, and you are starting to get some traffic from other regions as well. Now your demographic was mainly centered towards, for example, Pakistan, but now a lot of the people that are foreigners, Pakistan nationals, but they are also using your application. Now it's coming to you that yes, you are getting a lot of traffic from, for example, UAE, and your application is getting very famous over there, and you want to go global. You are decided, yeah, I'm going to replicate my application into UAE as well, so that users can actually easily use it, and I can market it on a very broader scale. So if you were using the traditional system, you had to go and procure your system infrastructure, set it up in UAE, and then go global from there. But for cloud, and it's in general in cloud, not just AWS. You can say it's in Azure, in IBM, in Oracle, in Google Cloud, anywhere. You can go global with the click of few minutes. You will replicate your actual data, your actual application, your dependencies into that region itself, and it's going to and if it's available in that region, and it's like you have now two regions availability. You have now a couple of things attached with that. Users can actually use your application which is closer to them, and at the same time they can actually basically have a safe fail safe as well. If your application goes down somewhere, your other region will be able to take care of that. So you can go global within a couple of seconds, just clicking that you just make available in this region as well. And another thing that I keep repeating as well, that you don't need to spend money on data centers itself. You don't need to buy hardware, and you don't need to buy even the electricity. You're not going to pay that bill, and you don't need to take care of cooling or stuff like that. I do get asked this question that yes, we still need to pay an amount. For sure, you need to pay an amount, but you need to only pay for the usage itself. If you go ahead and buy a server, and let's say you buy an AC as well for that particular server, now you own those two servers. For example, you were only going to use it for a month, and afterwards you don't need those servers. but you spent money on them, and now you need to take care of them. You need to ensure its school, you need to ensure its security, not just security in general in virtual environment, but security of the actual hardware itself, the physical product. So that is going to be on to you. But if you are in cloud, you will have the same thing. You use it for a month, and then that's all. You say, okay, that's all I needed to use. I'm going to pay you for a month, and we can say goodbye. So that is different in terms of you're going to pay for that usage. No, you're not actually paying for the actual ownership of the particular product. So it's a bit different when you're talking about these two. Now, it's going to increase your speed and agility. And I want to stress this a little bit, that it's going to increase your speed, but it's not going to increase your internet. You see, people sometimes say that, yeah, I hosted everything, but my user is not able to access it, even though I have the infrastructure in the best possible manner. I have it so over provisioned and stuff like that. No, that's not the case. It's a bit different. If your user has a 100 kb internet, then that's not up to the application. As soon as the application gets user's request, it's going to process it as soon as possible. It's going to mark, and it's going to make your application a lot more robust, because they are available in a very broader infrastructure. It's going to give you the possibility to use some services that are more compatible. But if you were to use them in an on-premise infrastructure, they were not going to be as easy to use or as cheap. So keep this in mind. Ability and agility of an application is a bit different than the user's interaction. Sometimes user internet will be the complaint factor, that I'm not able to access, but it's not your application. Of course, there are going to be application related bugs and issues as well. But I want to stress this, that don't confuse this with the internet speed and the agility of the application. And then there is also a stop guessing capacity. So if I'm not sure that how much data my 1 month will generate, I'm not confident enough, and I can only make guesses if I'm trying to procure the system itself, the hardware. I can make a intelligent guess, like, okay, I'm getting data 1 GB data per day, and then it's going to be a 30 GB for a month. Let's just go being safe, and let's go with 50 GB. But what will happen is, if I made all the guesses completely correct, but at the end the data I got was more than the 50 GB. What happened is, after 15 days, the user interaction grew by a lot, and at the end I got like close to 70 GB. So cloud is going to allow you to basically use not guess capacity, but be on demand. That as your data grows, it's going to charge you more now as your data is growing. But now you are in a very safe haven, that you are not missing out on anything. You're going to pay extra for that demand, and your guess was not correct this time. But at the same time, you avoided an unfortunate event, that you need to go and run to the market and get another system. No, it's going to elastically improve your capacity itself. And a lot of the time when we are talking about capacity, we are referring to storage itself. And storage is elastically increased for your current circumstances. You're going to pay for the on demand, that this much you use, and that's all. So, and when we come to the idle resources, it's going to be the example for AWS Lambda. You're going to pay for 5 minutes that you used. Other than that time when your code was just saved over there and your application was not running, you don't need to pay anything. Okay, so your code is there, and you can stop. You can wait on the AWS Lambda UI screen, or as much as you want. They're not going to charge you. But as soon as your code starts the execution, it's going to start the timer. And once it's finished, it's going to tell you, yeah, this much ran, and you need to pay me for this much amount. And trade capital expenses. For variable expenses, it's the same. You don't need to have a million rupees to start your venture, but you will have a very expense like this month you might get charged for 10,000 and next month might be 9,000 or 13,000. So you trade that upfront capital with a variable expense. It allows you to make money so that you can afterwards invest into your business rather than just guessing it from the get-go and indulging a very huge amount and afterwards not able to recoup your complete cost and going in a loss. What you can do is start from small and then slowly move towards making a bigger jump for your infrastructure itself. So yeah, we have some any practical examples of AWS. So we're going to have, I'm going to give you examples, but in terms of examples, they will be just the usability of AWS. We're not going to go and do any hands-on in this session. It's not hands-on related. It's just an intro itself. Okay, so it's just what different services do and how we use it, and if someone wants to get started on AWS, where you can actually start. For actual hands-on, it takes more than 1.5 hours to actually go through complete picture of the story. That yes, you can store the data in Amazon S3 from drag and drop as well, but there are many other factors through which you can do it. And the other question is for AWS: is it necessary first to become a developer? So no, it's not completely correct. You can be a developer and AWS developer as well, and you can be. So the question, the definition of developer is very bit vague. Some people are using AWS services to take care of some what you call operational visibility, and some are actually developing some databases over there. So they are all developer in that sense. If your question is that you need to learn a specific language or you need to be aware of a specific thing, then it's a bit of an advantage. What I'm talking about is that if someone has a knowledge of a particular language and they are more used to it in terms of course they are better going to perform in a cross functional environment. And cloud is a very broader area, and if you have cross functional capabilities, then it's going to allow you to do a lot more, because you are not bound by the hardware itself. You are bound by the knowledge itself you have. So you might there are some things that your logical understanding are also important. So I'm not going to say that having a particular skill of being a developer is necessary to get started with AWS, but it's a very good skill set to have, and you might be able to find a niche area in AWS itself for using your skill set. But at the same time, it's never too late to start. If you you are hesitant to learn because you are not a developer, then I don't think so you are making the right judgment over there. You need to as soon as you start, you might understand that yes, I'm good with AWS, but it's not the code development that I am very good at, but it might be that I'm very good at taking care of the infrastructure itself. I'm a very good DevOps engineer. So it's there are advantages to having a certain skill set in each and every industry. So yeah, recording. I think for recording, you might need to consult with Rida. But at the end of the session, do remind me again, and we can go back to this question. Okay. Now the next so advantages of cloud, we have gone through it in a very detailed fashion. We have cost reduction, and cost reduction is going to that you don't need a capital expense to run an environment. You don't need to pay an amount, and you don't need to do anything like that. What you need is a variable small cost that you need to get started, and you only pay for what you use, not for anything else. You don't need to pay for the security, the physical security or of the system. If you are running EC2 instances, then yes, you need to take care of or any application. Virtual security is going to rely on you, but the security of the AWS cloud is going to be ensured by AWS. It's you don't need to worry about in that department. Then we have the scalability factor that you can grow easily, and it's going to be elastic and on demand provisioning. So you don't need to worry about, you don't need to guess anything. As your data grows, your um, it's going to scale out in itself. And of course, there are a lot more details in depth if you're talking about on demand and stuff like that. But in general, it's very scalable. Agility is going to be the same as other things. Your system can be very agile, and if you are using some of the other features that are available in cloud, that are using the full power of the cloud. An example I gave earlier was having read replicas for data stores. So what they do is they don't make any changes into the data source. So if you have any change required, then you need to go to your master data source anyway, which could be like in the US. So it's going to hamper your agility. But if you are reading from a read replica, it's very fast in terms that it's mainly built for reading purposes. So it's going to read from replicas, and you can have read replicas in many different regions, like you can have in UK, in Europe, in Australia, in India. So read replicas lie in many different departments, and master can have a place in itself where changes are actually happening. And then we have the reliability factor. So you have multiple regions available, you have multi AZs available, and there is disaster recovery offering and security. Now security is going to be a topic that if you are using services that are that give you more operational control, then it's going to be a little bit different, that you need to take care of the security. But if you're using services that are serverless and that are managed by AWS, then the security is going to be ensured by them. And multiple sites is referring to multiple AZs. So when we are talking about multi-AZ infrastructure, it's usually that you can have an application and simple checkbox like thing. You need to ensure that it's available in multiple AZs. Usually Amazon ensures that when you are building that application, it's going to refer you that these AZs are closest to you. So but if you are building an application from Pakistan, but it's meant for users to be used in Europe, then you might want to ensure that these AZs are actually in Europe and not in my demographics. So that is their possibility as well. And higher availability, once you have a same application available in multiple AZs or in a multiple region infrastructure, it's going to make your application highly available as well. So your users, if sometimes your requests are a lot more heavier in terms of Europe, and your other regions are available to be served for other customers, and you and AWS realizes that the time using the some services, the time needed for a user in Europe to request these services in Europe is a lot higher as compared to just going to another region and getting those services from there. So it might be better to just go in a very different region. So it's going to ensure that. Of course, a lot of the details are there in terms of going more in depth, how we can use an multi-tenancy and what are centralization. So we are not going to go in that detail, at least in this one. You have high availability, we have gone through that. You have elasticity, you don't need to guess, it's going to be elastic. Agility of the system is going to be very agile in terms of how you want to operate it. You want to go global, and it's going to be durable because you have the capability of replicating it in different places, not just have it in one place in itself. Okay. And these are some of the AWS services that are available to be utilized. And I'm going to just give a one-liner because I think we are running out of time as well now. And I want to use the last 5 minutes to have answer any questions, or I want to share some resources that you can actually use to basically get started on AWS. It's very easy and it's very open to public kind of thing. So there are different segregation for these ones as well, like deployment, application services, and foundation services. But more or less, they come under AWS umbrella. So it's not going to restrict you in any fashion. You can use them as it is. Some of the services that I'm familiar with is Amazon SQS, Simple Queue Services is a messaging service. Then we have stream services, which is going to be the streaming cloud search. I'm more for AWS Cognito. It's a service. So to give you an example, it's a service that you use to sign in using different authentication provider. So, and a common example is whenever you go to a site, it gives you an example if you want to sign up using uh, your Gmail account or your what you call LinkedIn account. So that is something. Then SNS is another simple notification service. Then directory services usually used to manage AD services. Then IAM policies, trusted advisor is going to tell you what are the flaws in your security system. Then there is config that you can check to ensure that the certain configurations are followed whenever some particular service is procured or run. CloudTrail is going to tell you who made changes and where you can actually go on an application level, check the CloudTrail itself. And then you have CloudWatch that is going to give you a metrics kind of thing. CloudFormation allows you to procure infrastructure as a code. This is a common this is a very common entity that is asked that what is infrastructure as a code. So AWS allows you to use UI to procure services, but at the same time you can use code and just procure this infrastructure in that manner. So what happens is when you're doing is this through code, it ensures that what previously you had procured is going to be the same for this new application that we are trying to procure. So it reduces the chances of your human error. So if you are aware and you're sure that this is going to be my capacity, I previously had it provisioned and it was perfect for my usage, and then you can make CloudFormation template from there and then use it again next time you need to use it. So this will ensure that the same capacity is provisioned. Not only is going to be concerned with one service, it's going to ensure all the services related in that package are provisioned in that same manner. So no errors are happening and no bugs and no human mistakes happening there. Okay. And then we have Kinesis, and these are analytics engine, data pipeline, and EMR. Kinesis engine has further 3 replications as well. We have compute Amazon EC2. We went in very much detail for the compute engine and for AWS Lambda. Then we have CloudFront, and these are still storage and content delivery. So I kept talking about read replicas, but there is another service called Amazon CloudFront, which allows you to basically put your data in Amazon CloudFront. So it's replicated over there. So specific region and specific demographic can be served in a very robust and timely manner. So you can put your data into Amazon CloudFront distributions. What will happen is that data, that specific content that you specify will be available in Amazon CloudFront, and you don't need to replicate your application, but that particular segment that you specify will be available in CloudFront, and then CloudFront can further provide it to the customer in their close vicinity. Amazon Glacier is a backup and a cold storage type of storage space. It's one of the types of Amazon S3, but usually it's segregated from S3. Is its usage is very different, and its data is not available on a click, on one click. It requires 6 to 12 hours if you put data in Glacier. So ensure that that data doesn't need to be accessed as frequently. And if you need to access data that is needed frequently, it's going to be Amazon S3. Amazon EBS is going to be the mounts that you put for OS. So these are the mounts that are actually used for data. So they are going to be mounted on EC2 instances. You can have multiple uh, EBS volumes attached. And then DynamoDB is an example. We did not touch DynamoDB, but this is the offering that Amazon have for your NoSQL stores, Amazon RDS, and Amazon Redshift. Redshift is for database house, and then Amazon Elasticache is your caching service. So it's mainly used to cache data for your Amazon Redshift forefront. Route 53 is the routing service that they have. Then we have Amazon VPC and AWS Direct Connect. We did not really cover networking in any fetch, but Amazon VPC is the virtual private cloud. So if you want to have a kind of privacy in the cloud itself, you want to have a networking layer on cloud, then VPC is the way to go for in this aspect. So these are some of the services that Amazon have. And lastly, this is a very typical data engineering pipeline. If you want to have you have a corporate data center, it's generating some raw data. You put that raw data into an S3 bucket. That S3 bucket. Now, before we go any further, it's going to lie in your AWS cloud itself, and in that cloud, you can emphasize that you want to have a virtual private cloud that is going to ensure that all your services lie into that directory. Okay, and it's going to put that raw data over there. You perform some ETL using another service like ETL, AWS Glue, and you process that data and put it in another bucket, that is S3 process bucket. So you have two buckets now, and then you crawl and put a data catalog and use Amazon Athena. Amazon Athena is another service, and this service is basically used in very similar fashion as Hive. When we are talking about Hive, it's an application layer. Your data is never in Athena itself. It's residing completely in your S3 buckets, but the definition how to read that data is lying in Amazon Athena. So whenever you hit run, for example, you are trying to get data from a table, it's going to basically have that definition, translate your underlying data, and tell you, okay, this is your data. So what is a crawler? Can you explain it more? So crawler, I'm not going to go into a lot more detail as we are running out of time, but I'm trying. Crawler is an application that actually goes through your data and tries to make some pattern. So what it in here in this example, this crawler is mainly meant to generate a data catalog that can tell me that what is the basically schema of the data, the process data. What is its schema? What are the tables? How can I read this data? For example, if in this S3 bucket, there is one table that has 5 columns and they are in a comma separated format. This crawler is going to generate the schema for that table and put it into the catalog. So whenever a user comes into Athena and reads the data, it can check the data catalog and tell, okay, for this table, the schema is this, and here is the data because I tried to write it from the S3 processing bucket. So for that, the crawler is the one who is responsible for actually translating that information into your service. So that is going crawl. And some other crawler in some other scenarios in other industries, they might be meant for a very different purpose. Some web crawlers are meant to get data and try to scrap data from different sites itself. So there are those kind of crawlers as well, but in this very particular manner, it's trying to understand schema or a pattern in your data, so that you can at least have a human readable format for your data. Okay. Okay, so we have 5 minutes, and there are a lot of other services, but uh, just I need to cover one thing, and I need to go to availability. So I need let's just try to quickly go through the use cases. So whenever it comes to data retention, I'm going to go through it quickly. If you have questions, just let me know and we can go through this at the end. But for AWS, some of the uses are data retention. You have your on-premise infrastructure, but you want to ensure that data is retained in a different area. After a certain time, you can use cloud over there. And even in cloud, you can have, for example, you're storing data in S3, you can have an S3 policy that basically traverses data into different kind of S3 buckets, not in just one. So what it will do is it will ensure that data is stored in a correct format, but also you are making your cost is the lowest as possible. Then you can delete or keep older data. That is another use case. You want to delete your data, but you want to keep some older data as well. Data is better than money. This is a code, but it's a bit focused towards industry, because industry prefers to have data because they know from that particular data they can make more money. And if you are not aware, do Google what are some of the data brokers, and you will see you might find some very big some names that are actually comparable to people, things like AWS and Google itself. So having data is a very big advantage over your competitors. But if you are starting your business, then this might not be your concern. Historical data, you can have historical data in your cold storage. Then archivals are glaciers and deep archive. And then there is another, you have AWS Redshift to directly query older data from S3. So this Redshift spectrum is still rather new, and it can allow you to even data from the S3 for older sites. Okay, we still have 3 minutes. Okay, let me share the resources I was referring to. Just 1 second. Let me share it. So if any of you guys want to get started, I'm going to share a couple of resources that you can start building on. I started my journey on AWS from here as well. If this is an offering from AWS itself. Oh, sorry. Yeah, from AWS Skill Builder. This is a very good platform. If you want to get started and you want to know what the first course should be, it's the Cloud Practitioner course. It's going to get you familiarized with AWS, and it's going to Cloud Foundations is the learning path, I believe, and there should be a Cloud Practitioner, complete AWS Cloud Practitioner Essential. You can start from there. It's an offering from AWS, and it's what you call completely free. You don't need to pay anything, and this is going to give you onboarded. You can and it's completely as you use it. Then there is the AWS free tier. You can use the AWS free tier to get started. It's going to ask you for a credit card, but you won't be charged for anything other than the $1 it tries to verify your card. Other than that, it's not going to charge you. But everything that is available in your free tier is, as you can see it on the page. Not only that, whenever you go and try to reserve some service or try to do anything on AWS, the free tier is basically it's going to tell you everywhere that this is eligible for free tier. You can use it this much. This is eligible for free tier. So you don't need to even remember that. Whenever you go into the service, it's going to tell you over there that how much it's available or allowed in free tier. And there is always free, but always free is different in terms of that free tier allows you on a very certain limit, not everything. And lastly, Udemy is another very good resource. The two people that I follow is Stephen and Neil. I'm more fan of Neil as compared to Stephen, so it's a little bit biased. But you can start from there. It's going to be paid, but the content is very good. Very good. Other than that, lastly, I think Dice has some courses as well. So if you want some instructor-led that you don't think you can do it yourself, and it's better to have a format and time schedule to for services uh, for understanding or learning. Then I think DICE has some of the very good courses in terms of analytics and even AWS. So you can start from there. It's completely up to you. Other than that, uh, I think that is all from my side. If anyone has any questions, they can ask. Other than that, I think I have gone through all the questions. I hope I did not miss anything. Let me just go through it again. Yeah, I got, you can ask for the recording for the email address that Zarang has provided in the chat. And, I think I have answered all the questions, and there isn't anything. Then it seems okay. So we have a question. Asim, do you want to ask a question? Asim, I have allowed you to talk. You can actually open your mic and. Asim, do you, is there any question? I don't think so. Maybe.
Okay, so I guess that's all about the webinar.
Yes.
To all the attendees, we hope you enjoyed the session. Thank you so much for participating. We have mentioned an email in the chat section. You guys can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk. Thank you so much, Mr. Muni, for conducting such an informative session. We had a great time on this webinar with you.
No problem. Thank you.